The next probability events will actually deal with compound events. Something happens, then something else happens. So we're actually having two things happening, one right after the other. In this case, we're going to see the word and. Usually when you see and, we're going to be dealing with multiplication. So let's look at this problem and how this formula works. So it says the probability of A and B happening equals the probability of A times the probability of B. So we got this jar and it contains marbles. 3 red marbles, 5 green ones, 2 blue ones, 6 yellow ones. That is our sample space. So think about it. We have 3 plus 5, 2, and 6. Total number of marbles. 8, 9, 10, 16. A marble is chosen at random from the jar. Then we're going to replace it or put the marble back into the jar, and then we're going to pull the second marble. We want to know the probability of choosing a green and then a yellow marble. So since we are replacing, there's the terminology you need to know. Since we are replacing the marble, this makes the events independent. When I pull that first marble, it's not going to change the second marble's probability because I'm putting that marble back in there. So let's do it. So green, the probability of pulling a green, that's going to be 5 favorable outcomes over our 16 total. Then we put the green marble back into the bag. So there's still 16 marbles. So then we put our hand back in the bag. The probability of pulling a yellow, 6. Then, in this case, since these are independent events, the formula says all we have to do is multiply the two probabilities. 5/16 times 6/16. Truthfully, I don't see. I'm not mistaken. 6 times 6, 36. 6, 7, 8, 9. I should know this by heart. 6. Oh, I knew that. It's 256. I knew that. So 5 times 6 is 30 over 256. We could simplify that fraction to get our answer. Main thing is, since these are independent events, we're going to multiply the probabilities.